G'day. This is the first of our videos about how to factorise quadratic equations. And in this particular video, I'm going to concentrate on a process called the cross method. Future videos will deal with other methods, but this is the cross method. And in order to explain it, we're going to look first of all at how we expand quadratic functions, or at least expand binomial products. If we have a product like this, I'll use two simple binomials. When we use the term binomial, we mean an expression that has two bits to it, two parts. So this is a binomial, that's a binomial because it's got two parts. And because we're multiplying them, we call them a binomial product. Now, the process of multiplying it out is called expanding. And you'll often see in a test something like expand that. Well, how do we do that? You'll hear about people talk about, use the term FOIL, and well, let's deal with that process fairly quickly. I'm going to show it in three quick ways. First is that if all of this multiplies all of that, then both these bits multiply that. So the x must multiply it, and the 2 must multiply it. So the 2 must also multiply the x plus 3. So already this has been expanded a bit. So we have x lots of that, 2 lots of that. They're the two expressions we now have, the two terms. Now we have x lots of everything in here. Now there are two things here. So we have x lots of x squared, x times x is x squared, x times 3 is 3x, now dealing with this one, 2 times x is 2x, and 2 times 3 is 6. We now have fully expanded this product. We have 4 terms, and if you look carefully, 2 of them are fairly similar. I'm going to circle them. I always circle a term with the sign in front because the sign belongs to it. It's plus 3 lots of x and plus 2 lots of x. And those two we can combine. The x squared's all on its own, there are no other x squareds. A 3x and a 2x make 5x. It's like 3 apples and 2 apples make 5 apples. And this is now considered fully expanded and simplified. This process is called simplifying. And this, of course, because it's got 3 parts, is known as a trinomial. Or, because it's an x squared expression, a quadratic. Now, that's one way of multiplying it out. Some people do this. We're going to inspect this. Sorry, that should be a 3. Some people use the acronym FOIL, meaning you multiply the first term in this binomial and the first term in this one. So x times x will give us x squared. Then the O stands for the outside ones. So when we're looking at this, the x is the first one we encounter and the 3 is the last one we encounter. They're the outside values. So we now multiply the x times the 3. X times 3 is 3x. The I stands for inside. If they're the outside, they're the 2 inside ones. And plus 2 times x is plus 2x. And the L stands for the last ones. And the 2 is the last value in this binomial. And the 3 is the last value in this one. So 2 times 3 would give 6. And you can see that by using FOIL, we don't have to fill out this line. We bypass it and we go straight to this one. You can see they're the same. And the result, of course, would be to add the 3x and the 2x and get 5x. So that's the FOIL method. Now, I find learning the acronym, for a lot of students, is a bit difficult. And you're going to wonder what the difference is between these methods at all, because essentially they're exactly the same. I get my students just to draw arcs. So they've got to multiply x by everything here. So they do x times x and x times 3. You see it's exactly the same process, just without thinking in terms of FOIL. X times x is x squared, x times 3 is 3x, 2 times x is 2x, and the 2 times the 3 is the 6. Same result. Now what's different? The only difference is we don't have to think what FOIL stands for. Believe it or not, I and my students call this the claw, a bit like a fiddler crab, I guess. And when I teach this to students, I find they're walking around like this thinking about the claw. And they find that an easy structure to multiply out. So whether you think about the claw or FOIL or go through the full expansion process, you can see the result's always the same. Now let's analyse this. You can see that the first term, the x squared term, is always that product, isn't it? The x times the x. That's not going to be a great difficulty. You can see that the last term is always the product of the last two values, the two numbers, the 2 times 3. It's the middle term that causes the problem in a sense because it's made up of 2 parts. Now, I'm going to draw this in a slightly different way so I can analyse it in a way that I think will be very helpful to you. So let's have a look at it. Imagine that I write these two binomials above each other. So here's x plus 2 and x plus 3. Now if I go through the process of multiplying them out, you can see I'm going to multiply the x by the x to get my x squared. I'm going to multiply the x by the 3 to get my 3x. I'm going to multiply this x by the 2 to get 2x, or if you like the 2 times the x to get 2x and the 2 times the 3 to get 6. So you can see by writing them above each other I no longer get a claw, but I've got this funny cross bow tie pattern. And we've agreed that the x times the x is not really a problem and the 2 times the 3 is not really a problem. You can see that this middle term is composed of the x times the 3 and the x times the 2, our 3x and our 2x. And it's precisely because of this cross that we get the cross method. So let's have a little look at doing this in reverse. I'm going to write this up here and then we're going to factorise it. So let's have a look. Okay. This is the way the question would be worded in a test. Where before we had to expand, that is multiply out a binomial product, here we do the exact reverse process called factorising. We factorise this trinomial in order to break it up into a product of 2 binomials. Now, the way we do it is this. We're aiming to have a product of 2 binomials. We know that the only way to get an x squared is x times x, so we can put that in here. And what we do on the side of the page is we draw across. Some teachers, by the way, teach this exclusively and swear by it, and a lot of students like it as well, but be assured there are other methods if you don't like this one. But you draw across and you write down the x and the x, knowing that x times x is going to give you x times x or x squared. So that's taken care of. I'll actually put a tick here, a check mark. Now, what we do on this side is we look for products that give us plus 6. Now 6 times 1 will do that. There's no point in writing 1 times 6 because x and x are the same, so we could flip these. It really doesn't matter what order they're in. So 6 times 1 will give us 6. I could do minus 6 times minus 1, because two negative signs make a positive. But you notice there are no minus signs in this at all, so it's a bit pointless introducing them. So 6 times 1 makes 6. The only other combination really is 3 times 2 or 2 times 3, isn't it? Now both these products will give me the plus 6, I'll tick that. And essentially what we've done is we've set up this structure. We've set up the x's, and we've set up this and another combination. Actually, here I've got the 2 on the top. I will reverse that just so it looks the same. The problem is we don't know which combination is right yet. Both of them produce this 6, but only one of them will make sure we get a 5 in the middle. And the cross method works this way. We actually check by multiplying along these diagonals and finding what the middle two terms would be. We could, for example, have x times 1 is x, and x times 6 is 6x. Now 6x plus x is 7x, and it's not what we want, so we know this is not the combination we need. If we look at this one, we get 3x, 3 times x is 3x, and 2x is 5x, and that's exactly what we need. So we can put parentheses here, and these are our two factors, x plus 2 and x plus 3. So in essence we're doing this in reverse, this multiplying in reverse. Now some students and some teachers don't like going straight to the product. What they do is this. Just imagine, I'll write it out again. X squared plus 5x plus 6. That's a bit awful. They write down the x squared, they write down the plus 6, and once they've worked out this combination of 3x and 2x works, they actually write it in. In other words, they break up the 5x into 3x plus 2x. Once they've broken it into 4 parts instead of 3, using this cross method, they then factorise the first 2 terms, and the only thing in common between these two, I think you can see, is the x. So they take the x value out. X times x will give me x squared, and x times 3 will give me 3x. And then they look at the last 2 terms and they look for what's common here. Now there's no x in common, but you can see the number 2 will divide into 2 and 6. So we take plus 2 out. 2 times x will give 2x, and 2 times 3 will give 6. And here you can see that we have x times this factor and 2 times this factor, same factor. So if I've got x lots of them and 2 lots of them, I have x plus 2 lots of the same thing. Now some people like the thoroughness of this and like thinking through it. You can see it's a complete reversal. If you wrote that first, then that, then that, then this. It's a complete reversal of what we just did at the beginning of the video. But many people, once they draw the cross and work through it, are happy to go straight to the factored form. That's the cross method. Now there are some complications when we have plus and minus signs. So what I propose to do now is to factorise a number of quadratic expressions fairly rapidly, using it to demonstrate some of these skills. And also towards the end of the video to show some of the difficulties with this cross method. Now, all I'm going to do for the remainder of the video is factorise these 3 quadratic equations, or quadratic expressions, using the cross method. So, because they're all monic, mono means 1, and monic means we've got 1x squared. I'm going to explain the cross method with more difficult quadratics in a later video, but all these are just monic. They're all going to break up into a binomial product with an x times x giving x squared. So this will be the same, and this will be the same as well, because all of them have a single x squared, x times x, x squared. So when I offer you my gift at the end of the video, I want you to practice doing just this with monic quadratics. If we set our cross up, we know it's going to start with an x times an x, and we look for combinations that multiply to make -3. Now -3 times +1 and +3 times -1, and really that's it. 3 is a prime number, so it can only be a product of itself and 1. And we've tried the minus signs, the negative signs in the 2 places possible. That's it. So let's check out. We now know that the x squared is taken care of. We now know the -3 is taken care of. Let's check the middle. Here we have -3x, multiplying these two, -3 lots of x, and 1 lot of x, or +1 lot of x. And -3 plus 1 is -2 lots of x. That is not what we want. If we check the next one, here we have 3 x's minus x gives 2 x's. That's exactly what we want. So x plus 3 is one factor, and x minus 1 is the other factor. I hope that makes sense to you. This method, this one here, using the cross method, is going to be x times x. They all will be, for this video at least. Now to get plus 24, we have a slight problem. There are lots of combinations for 24. 24 times 1. I was going to leave this quadratic till last. This is the one that shows how difficult the cross method can be at times. No, fortunately we don't have a minus sign, so at least we can make sure everything's positive. Otherwise we'd have to try -24 times -1 as well. What other combinations? We have 12 times 2, and 8 times 3 make 24, and 6 times 4 make 24. So we actually have 4 combinations. If a minus sign had been here, we might have had to try negatives through all these, and maybe even -24 and +1, and +24 and -1. It can get very tacky, and you can actually have to write lots of combinations. That's the major drawback, by the way, with this method. And the next one I'll demonstrate is a bit faster, a lot faster. But this is a classic method. Well, we have our x squared taken care of. All those combinations on the right hand side here, all of them multiply to give you plus 24. We want the combination that gives plus 10. Well, I think you can see 24 and 1 won't. And 12 and 2 won't, that's 14. And 8 and 3 makes 11. Now I didn't plan that it was going to be the last one, but it is. 6x and 4x make 10x. So it's this combination works, and it's x plus 6 and x plus 4. So if we multiply this back, you would get x times x is x squared, and 4x and 6x makes 10x, and 6 fours are 24. And there's our foil or our claw again. Last one, and this should be a lot easier. 12 still has some combinations, but it's not quite as bad as 24. Let's draw our cross. X times x gives us our x squared, so I'll tick that, or check it. We call it ticking in Australia, checking in the United States. Now we need a plus 12. Well, we could do 12 times 1, but I want you to notice that the combination is negative now. Now the only way we're going to get a negative number here is if we have some negative numbers over here. And the only way we can have negative numbers here is if we have 2 negative numbers. So minus 12 times minus 1 gives me plus 12, because this is positive. So all of our combinations are going to have 2 negatives. Now minus 12 times minus 1 works. What else makes 12? Minus 6 times minus 2 makes plus 12. Minus 3 times minus 4 makes plus 12. And I think that's it. I think those are the combinations. Now, all those combinations will give me a plus 12. I could have written 12 times 1 and 6 times 2, but we know they're not going to give us a negative 7. So we can at least save ourselves some trouble. Here we've got minus 12 minus 1 is minus 13, not minus 7. Minus 6x and minus 2x is minus 8x. And again, unplanned, but it is the last one, minus 3x and minus 4x does give me minus 7x. So my combination is x minus 3 times x minus 4. And that is the cross method in action. If you like it, particularly after you've looked at the other videos, if this is still your preference and your preferred way of working, it does have some strengths. Then please practice it till you become very good at it. Now, in order to practice, I'm going to put a link below this video to an Excel workbook that I created, and it's on my website. You can download it for free. I assure you that unless someone else has tampered with it, it certainly is virus free and quite safe. All I've done is randomise formulae that generate these kinds of quadratics. In fact, this particular workbook you can use for all your quadratic methods of all different kinds of quadratics, even the most difficult, and even the ones that are not soluble, not factorisable and don't have roots. If you would like it, then by all means go to the link and download the workbook and try it out. And if you do like it, please leave a comment below the video to say so. But just to demonstrate, I'm going to show you a little clip now where you can see that there are a number of tabs across the bottom of the screen that allow you to look at monic and non-monic quadratics and perfect squares, difference between squares, using the quadratic formula and so on. It's all built in there. And in each case, when you look at a particular sheet, if you press the F9 key, it will use the randomising process that Excel has to create random combinations of quadratics for you to practice. So you don't have to go looking up a textbook somewhere to find lots of examples. This workbook will produce everything you need to learn to factorise quadratic equations. Not only that, the answers are on the right hand side of the page, and I encourage students to print a page off, fold the right hand side under, just fold it back so it's out of sight, or you can tear it off if you wish, but folding it's easier. Solve the quadratic equations, that is factorise them, and then you can open up the answers and have a look at your results. I have found this a tremendous tool. It took me many hours to put together properly, but it's yours for free, and it's yours for free to share around. I don't give you permission to make money out of it, that's all. So give it away freely to your friends, your teachers, or if you are a teacher, you can give it to all the members of the class, and everyone can become very, very fast at solving quadratics. My intention is that you get to do most of them in your head, and you can practice enough to get that good. So anyway, having said that, if you like the video, please click the like button. If you have comments to share about the video or about the workbook that I provide the link for, then please leave your comments below the video. And of course, if you haven't already subscribed, I encourage you to do so so you'll learn about the future videos as they appear. And as always, I thank you very much for watching.